So let's take a look at this one. We're just solving an exponential equation. We're going to use the properties of logarithms. We're going to use inverses to solve. Remember, anytime you have a variable in the exponent, the way you solve it is by using the inverse of the exponent. So in this case, it's easy to use the natural log, but you can use actually anything, any base for a log. I'm rambling. All right, so I'm going to use the natural log. I'll take the natural log of both sides. When I do that, I can use the power rule that we talked about, or that you remember, hopefully. So then I would have 0.05t times the natural log of e. Remember, the natural log of e is just 1, and equals the natural log of 3. That's just some number. So I'll divide this side by 0.05, 0.05. And that just leaves me with t. So I get t, or t times 1, but that's the same thing, ln of 3, 0.05. So it's really, really simple. Anytime you want to get the exponent out of the I guess any variable out of the exponent, then you use logs somehow. There's another example that I want to show you because I feel, again, people might get confused or freak out on this. So take a look at this. This one is definitely a little bit more weird. So let's think about this. The first thing I thought is, well, if I take the natural log of both sides, it won't work because I can't just take the x's out. Why? Because I have an addition there. So, I mean, this is raised to the 1 power. I can take a 1 out. That's it. So I can't really do anything there. So I won't take the natural log of both sides. Then I was thinking, well, what can I do? Well, I could rewrite this. 2 raised to the x plus 1 over 2 to the x equals 5. And then I thought, okay, now I have a fraction. I can clear the fractions by multiplying both sides by the denominator. So I can do this. See if that helps. I mean, that's allowed. So let's distribute. This would become 2 to the x times 2 to the x, so that would be squared. And then I would have plus 1 equals 2 to the x, 5 times 2 to the x. Maybe I'll write it like that. Okay, that's great. I still don't know what to do. Well, here's the thing. This is like a special algebra 2 problem. We spent a little bit on this. This actually has now a quadratic form, right? Because it's squared there. So I'm going to get everything over to one side, and then I'm going to use some substitution. So I would have 2 to the x quantity squared. I'm going to subtract this over, so minus 5 times 2 to the x plus 1 equals 0. And I'm going to say let u equal 2 to the x. We're using substitution here. And then I just have u squared minus 5 u plus 1 equals 0. Now it's just a quadratic. I can solve this quadratic for u, and then once I have u, I can plug it back into this equation and get x. So let's see what that looks like. So right now I'm solving this quadratic for u. I guess this is a review on quadratics. You can multiply those two things. This would be 1. This has a coefficient of 1, so I can use a shortcut here. And then negative 5. What times what gives you 1? What? What times what gives you 1 but adds together to get negative 5? Nothing. So we got to use the quadratic formula here, I think. I'm not going to show you all of that. I mean, I'll use x equals opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So I'm using that, and I get x equals 5 plus or minus the square root of 21 over 2, I think, hopefully. So that's some nasty number. I don't really like it, but that's, if you can't factor it, which I can't, then you solve it like that. Or you can always just solve it using the quadratic formula that's always available. Alright, so now I have an x value Sorry, not an x value, a u value. I messed that up. So that's my u value. That's my u from here. And there's two of them. Maybe I'll write them separately. Yeah, I'll write them separately. Now that I have these u values, I can plug it into this equation. So that's what's going to happen. I'm going to take these and put it over into that. So u for my first option, plus 21 square root, divided by 2. Let that equal 2 to the x. Now, if I'm going to solve it, well, I'll write the other equation as well. 5 minus square root of 21 over 2 equals 2 to the x. They're almost going to be the same answer. Almost, almost, almost. Alright, now I want to solve for x. How do you solve for x when it's in the exponent? Take the natural log of both sides, or some log of both sides. So that's what I'll do. It's pretty gross looking, but that's okay. So now I can take this, put it down. So I have ln of 5 plus square root of 21 over 2 equals x ln of 2. So I'll divide both sides by ln of 2. So it's not too bad. Ln of 2. So the first case, x equals ln of 5 plus the square root of 21 divided by 2, all divided by natural log of 2. And then also the negative, or actually we can just do plus or minus in there because it would be the same steps for that. So hopefully, we don't need that. That wasn't too confusing. There you go.